Okay, hi everybody. Thanks for the nice introduction already. Some of the aspects that have already been mentioned actually eliminate the need for me to go much more into detail what LLMs actually are and to focus on how LLMs impact localization workflows and CAD tool development. Just a word about STAR to begin with. What we actually do, we have a wide network of STAR offices all over the world with 35 plus years of experience and more than 950 specialists. So we are one global partner. But what is even more important actually is the products and services that we offer, because we are not only an LSP selling translation and localization workflows and services, but we're also a technology provider, which is actually a great benefit for us, even currently with LLMs and the fascinating things that are evolving around us. Because as an LSP, we can identify core problems or issues in the translation and localization workflow, and then have a response with regards to translation technologies, how to best support our clients and language professionals. So what you can see here is a brief overview of all the products that we offer from A to Z: content creation, translation, machine translation, in-country reviews, etc. So we have a broad range of products and services that we offer, which puts us in a very nice position because we know both the LSP world and the translation technology world. So yeah, what's on the agenda today? Actually, not going too much into detail, but yeah, a little word on AI hype. Then we will move on with challenges in localization that we're still facing. I mean, machine translation has been around for a while, but we're still struggling to use the technology in the most efficient way. So that's where actually large language models can play a very nice part. Then we will talk about CAD tool integration. So as a CAD tool provider, as we are always looking into how to improve things and how to use new technologies to best support language professionals. I will share some of our concepts and visions, a project that we started last year, in the middle of last year actually, LLM integration in our software suite. And then we will, for a conclusion, have a look into trends in 2024. So when we go back actually to 2023, I mean, this should be known to everybody, the Gartner report on the hype cycle for artificial intelligence. I mean, there's a lot of stuff to it. Maybe it's even hard to read for you because it's so tiny. But what matters to us the most is things like data labeling, prompt engineering, generative AI, and semantic networks. These are currently topics that we're looking into bringing them into the translation technologies and workflows. And of course, I mean, autonomous driving and robotics is also a very nice field of application, but that's nothing that would be of an interest to us. So today, I will be talking specifically about how we can integrate these technologies into the localization workflow. And before we talk about that, we actually have to have a look at what's happening in localization today. Because let's face it, since 2017, a lot of things have happened. I mean, we have neural machine translation, first introduced by Google and by DeepL. But basically what we're doing today is using a combination of different translation resources. So we have translation memories, we have terminology databases, and everything that's not covered by these resources is now sent to machine translation systems, maybe also or already to large language models. So we retrieve results or translation suggestions from these systems. We do post-editing, light post-editing, full post-editing. And yeah, it's an entire process, but sometimes it can be rather inefficient. Maybe because the traditional translation resources that we're using are not good enough. Maybe the empty systems that we're using do not deliver good enough quality for post-editing. So there is actually a lot of potential to use large language models for smaller tasks. And what you see here, symbolized by these stars, as Marta already mentioned, there are a couple of use cases for large language models. And these are actually the ones where we see the greatest benefit in. So source text creation, of course, but also source text optimization, translation memory enhancements, augmented translation for machine translation. So not replacing machine translation entirely, but use neural machine translation as a good basis and then put the LLM on top to fix stuff. Terminology, translation, quality assurance. So yeah, these are actually the fields we're currently looking into because throughout the years and a lot of experience in post-editing, we have identified a few key areas where we are still lacking quality or experience or efficiency to work in the best way intended. So we see that there's a problem with source text quality. So a lot of clients do not have proper style guides, or they have a very good terminology database, but they are not using it in the content creation step. We see a huge problem with terminology management. So while there are systems out there that support mono or bilingual term extractions and quality checks, there's still a lot of manual effort involved for terminology extraction specifically. And terminology integration and MT glossaries does work quite differently for different systems. You have terminology integration that also does morphological changes. Then you have more advanced models that are context sensitive, but not all machine translation systems and glossary integrations are created equal. So there's a lot of differences in there. Then we see a problem with quality assurance. So we have a few metrics lying around here, like linguistic quality assessment and MT quality estimation that work quite well, but still need manual effort for being analyzed or interpreted. So there is some need for automation. And we see that post-editing sometimes is not really efficient because we have inconsistent MT output, even with trained models. Models trained on specific data. And we see that post-editing distance, which is a very important metric to measure the reduction in typing effort during the post-editing process, can be quite hard to analyze because currently the metric does not show what the cognitive effort was involved during the post-editing process. Yeah. One problem or one way to solve this can be the use of MT glossaries. I'm not going too much into detail, but if you, for instance, have a look at what DeepL is offering, the MT glossaries have been around for quite some time now. So DeepL first produces the generic output and then looks into your MT glossary and checks whether a match is found. Usually the corresponding part of the sentence is then replaced and automatically amended in terms of morphology and syntax. So if, for instance, you have two general terms in your glossary, this can be quite catastrophic because DeepL is not context sensitive. So the adapted translation is then not revised for semantical correctness. So if there is a too general term in your MT glossary, this will actually do or have the adverse effect. So it will actually destroy your MT output. Taking this example here, marketing of the product is set. It's actually supposed to mean discontinued, but DeepL is forcing the preferred term that I give it to it. So yeah, the output is actually wrong. Or what's even more interesting or helpful, actually, when having a look at the DeepL glossaries, it can compensate for minor differences if the normalized form of a verb, for instance, is not used. So you can see here, the German beachten is an infinitive form, but the English equivalent is in a gerund version, so adhering to. Sometimes it actually gets that there is something wrong with the form, so it automatically adapts it in the output. But in other cases, if you introduce a colon, for instance, it won't do the same thing. So it will actually create a sentence that doesn't make, from a grammatical or syntactical standpoint, any sense at all. So really, the problem we are facing, and I mean, this is just one example of the problems that we're facing when working with machine translation without dedicated LLM integration, is that most MT glossary solutions are capable of making morphological changes automatically, which can save some time. But not all of them have built-in, like I call them, reality checks. So they're lacking context sensitivity. Working with empty glossaries, therefore, requires a thorough understanding of both the source and target language, and it also needs a sophisticated risk management and obviously time and resources to take care of empty glossaries. So handling empty glossaries is basically all about understanding that creating them doesn't happen overnight or within seconds even. And that advanced terminology management is highly needed today because the more attributes, the more context we can deliver to the systems, much more consistent the output will be. So this is a very important aspect these days. So yeah, I talked about challenges in MT, but actually this presentation is about large language models. So yeah, as Marta already said, large language models, they are highly capable of processing large volumes of reference data, and they can help to achieve more tailored output when fed with the right prompts. But of course, they also can be really expensive depending on the use case. When we have a look at ChatGPT, I think it would be rather, well, I would rather not recommend using ChatGPT for translation entirely, because the more reference material you send to the API, the more you will pay for it. So the question for us really is, what do we do with large language models? And that's a question that we have for, well, quite for some time now. And the best answer at first we could come up with is, what are large language models? And you saw that maybe on the first slide. They're puzzling. No pun intended. Yes, pun intended, of course. Because what do I mean by puzzling? Puzzling actually, well, they are actually quite hard to understand in their core. But what we are trying to achieve is to make this like a little puzzle game. So, I mean, the translation process today is quite straightforward and quite linear. So we have terminology databases, translation memories, we do pre-translation, then we send it to post-editing. So the process is quite linear. But the question for us is, how can we make that a puzzle game? So introducing little puzzle pieces of these LLMs into the process to compensate for problems, issues, inconsistencies that we normally get when working with machine translation engines. So yeah, we were thinking about what can they actually do? What is the potential use case of large language models for the translation or localization workflows? And one of the key aspects that we're examining currently is the direct integration of translation resources without dedicated training. Because what we in some cases can do, of course, is to train proper hybrid or customized engines for all our use cases. But in some cases, we can't even feed the machines the right amount of data to actually to achieve a benefit when using a hybrid system. So the question really would be, do we have an on-the-fly solution where we can use a generic engine but still have some customization through, feeding the engine or the LLM translation memory files or data? So one of the use cases might be something like fuzzy match adaptation, using a generic neural machine translation output and then enhancing that by providing the LLM with a fuzzy match from the translation memory. Then adaptive editing, of course. Adaptive editing has been around for quite some time now as a concept, but what does adaptive editing actually mean? So it means you're post-editing a sentence and the LLM has a look at the final translation and can actually retrieve information on what has been changed and apply these changes to segments that are highly similar to the segment that the translator edited. So on-the-fly editing or on-the-fly learning. Terminology integration is really crucial because, as I said in the beginning, we are working with different NMT providers, and the ones who offer glossary support, they want different formats, they want different files. So for us, it would be quite hard to provide all of these different MT providers with different file formats. Highly resource intensive. So terminology integration could also be a very nice solution. And terminology extraction, of course. Sometimes when you're working with a new client, they don't have any terminology at all. Maybe they can provide translation memory data, bilingual files that we can use to do a rough first terminology extraction, to build up a terminology database, or to provide an MT glossary if they want to go with an MT solution right away. Source text optimization, not only in terms of fixing typos, but also amending inconsistencies, terminological inconsistencies, and stylistic modification of the MT output. Let's imagine you're using a DeepL or Google Translate as a generic engine, but you want to steer your MT output in a very specific direction. You have a very specific target group. You want to facilitate sentences or use an easier language or an easier style for your target audience. That's something that LLMs can be used for with the right prompt to enhance or augment your existing output. And because of the lack of time, I'm not doing that in ChatGPT specifically, but I'll just share a little prompt sheet with you. I hope everybody can see it. What can be done? Because as Marta already said, the ChatGPT output can be quite inconsistent from day to day. So just provide you with a little bit of an insight what could be possible, not only through the web interface, but also through cat tools. I get to that later on. So fuzzy match adaptation, something like translate the following sentence from German into English and then match that to an existing reference translation. So that's basically what could be done in order to have a more consistent output in line with the existing translation memories. Then you have adaptive editing. So you, let's say, translate a sentence from German into English, and then you receive the output from ChatGPT, and then you're making some changes here. These changes are maybe not, well, terminological changes, but you want to change the structure a little bit. And the good thing about that is actually in this example, ChatGPT will recognize that you, instead of saying with its combination, you're switching to combining, blah, blah, blah. It will actually reproduce these sentences or these structures and apply them to a completely different sentence. So it can actually recognize what kind of change was made. We can actually, why don't we just, continue with the next example and check that in ChatGPT. Terminology integration, for instance. That's something, translate the sentence below into English and use the following terms for Energieinhalt, capacity, Leistungsfähigkeit, performance. It will actually use these terms. And maybe something even more interesting to have a look at right away in ChatGPT is terminology extraction. Terminology extraction is actually one field for the LLM where you have to be very specific. And that prompt over here is not overly specific. I kept it rather simple. You can actually enhance it. But what I want to do here is take the following text. So we have a German text and the English translation. And then you ask ChatGPT to extract all relevant terms from it. From the technical domain, only compounds, and ask it to present them in a table, German term, English term, and a reference sentence, because maybe you want to add that to a terminology database and you need additional information. So yeah, we'll just do that and see what ChatGPT does for us. I might have to switch to a, yep. Okay, kick me out. So, okay, not gonna do that. It's not responding, sorry. Okay.
how many guys we have.
Okay, sorry for that. It's currently not responding, so we have to skip that part and maybe have a look at it in the breakout room. CAT tool integration. What is our vision actually? So what role will CAT tools play? Basically, what we consider a CAT tool is the central repository for translation resources in the professional context. So for us, it's still, even with LLMs and NMT being around, it's still a very important hub connecting the project managers, the language expert, and all the related resources. What we are trying to achieve is to integrate AI for project preparation, processing, and delivery, so that in the end, we can achieve a process that we call internally augmented translation. So by using these puzzle pieces, we want to achieve an intelligent interplay of different translation resources. So the human translators are the main drivers and the AI becomes the co-pilot. What we really want to stress here is how important the conscious use of AI technologies to generate, control, optimize translation suggestions really is, and also for quality assurance. Because at the end of the day, we have the language experts managing the process, and they want to make the best use of modern tools to increase quality, productivity, and efficiency. So as I said, we're trying to get away from the linear process, and we are trying to turn that more into a puzzle, into something more modular. So what does that actually mean? What does CAT tool integration mean for us when looking at large language models? Our principal goal is, with the integration, not to replace the classic neural machine translation models for translation processes, but rather complement them through the smart use of AI tasks. So what kind of AI tasks are we actually talking about? We are talking about measuring quality. Internally, we have something in place that's called the MT Confidence Score. So that's an MT quality assessment based on automated metrics. That's something that can already be achieved without using large language models. So basically, when you're in the editor, you will get an instant feedback on the quality of the machine translation output. But what's even more important, and that's where LLMs can jump in, is the MT evaluation, because while you get a first idea of the quality of the MT output through these confidence scores, you also want to know how much of an efficiency impact does the use of machine translation or LLMs actually have. And currently, while we have something like post-editing distance, there's currently no 100% reliable model that analyzes and predicts the impact of certain error categories on translation efficiency. So that's where LLMs could come in. The other important aspect is, of course, basic prompts, providing in the CAT tool basic prompts and custom prompts. So here's just a selection of what we could be looking into. Language optimization, like switching from normal to plain language, applying gender appropriate forms, having localization or language variants, applying style guides, matching the TM, applying length restrictions, fixing tag issues, and even producing more or less, this still needs to be explored, of course, SEO-optimized translation. And then also offer the user a custom prompt, so an editor for adding their own prompts. Let's say, for instance, they have very specific consistency checks in terms of terminology, syntax, and variants. That's something we can provide. Doing the quality assessment, depending on the predefined model. Different LQAs come with different models, and LLMs can be trained on different models. Source text check and classification, and also some sort of domain recognition, which is a very crucial part for doing terminology extraction. What about resources? Of course, AI or LLMs can be used for translation, but as I said, if you want to achieve similar results to a hybrid MT system that is trained on customer or domain-specific data, you have to spend a lot of money sometimes, or currently with the current prices, because if you send your entire translation memory to the AI to take it into account during translation, this can become quite costly. So you can either operate with smaller models, or if you're working with attributes, reduce the amount of reference data that is sent to the AI. Terminology management is, quite frankly, one topic that we prioritized in our research, because terminology is important to so many processes in our workflows that we decided to make this a priority and have a look into the capabilities of LLMs in terms of that. So terminology cleanup, for instance. When we have a look at our own workflows and the data we are provided with, we often see that there's quite a discrepancy between the dictionaries and the translation memories. So a systematic comparison of glossaries and translation memories to identify inconsistencies or incorrect entries can be highly valuable. We do a lot of terminology search and research. Sometimes we also augment existing translation or terminology databases because they're lacking additional information like context information and definitions. That's where generating translation suggestions and requesting definitions can come in quite handy. Integrating LLMs to, with prompts to achieve more detailed or more precise results can be a big benefit. And one more important aspect that I also talked about much earlier is terminology extraction. So using machine translation or large language models to create glossaries with or without existing translation memories. So what's our mission? To provide you with a little bit of an outlook. In the description for this presentation, I talked about democratizing AI. So how can we actually do that as a CAD tool provider? Well, obviously, while doing so, we need to provide a creative environment to our users that is somehow tangible, so that answers the question, how seamlessly are AI tasks integrated into the set of translation resources? It needs to be self-explanatory, because let's face it, not everybody is a computer scientist. So the question we would like to answer with the implementation was, what is the intended purpose and what can the AI task do for me? This needs to be very clear. How easy is it to use? So how easily can the AI task be accessed? And is it right where I need it to be in the translation editor, obviously? And how motivating is the use of LLMs in my CAD tool? So how easily can I create my own prompts to achieve better results? And how does the CAD tool support me in finding the right strategy, running tests, improving the results, and then recognizing what was changed throughout the different prompts and take that as a solid basis for the final prompt. So for us, using AI in the localization process should actually be not overwhelming and very intuitive, or as intuitive as working with traditional translation resources. And finally, empower the users to achieve more fit-for-purpose translation output quickly and efficiently. And to end that session, I actually talked a lot about ChatGPT. The question really for us should be, while we are aiming to have these smaller AI tasks, do we really need a full-fledged system like ChatGPT, or would it be more advisable from a resource perspective to work with smaller models that are more specialized on certain core tasks that currently we are struggling with? So yeah, that's it from my side. I have a couple of slides, but we're running out of time. These are just some examples, but the slides will be shared anyway. So yeah. Thank you for your attention. If you're curious to learn more, feel free to visit our website at stardeutschland.net. And make sure to follow us on LinkedIn for the latest news and trends. And thanks again for your attention.